Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to business mathematics and statistics. This is lecture number 34, chapter number 8, basic concepts of differential and integral calculus. In this lecture, we will study about higher order differentiation. So, basic idea about higher order differentiation. Let y is equal to f of x is equal to x raised to 4 plus 5x cube plus 2x square plus 9. Now take differentiation dy by dx. d by dx of f of x is equal to 4x raised to 4. Here you have to use d by dx of x raised to n. N into x raised to n minus 1. Remember this formula, okay? So 4x cube plus 15x square, same formula, plus 2 square 4x is equal to f dash x, constant 0. Since f of x is a function of x, it can be differentiated again. d by dx, dy by dx is equal to f double dash x. So d by dx of 4x cube plus 15x square plus 4x. So take another differentiation, second time differentiation, okay? So d by dx of 4x cube plus 15x square plus 4x. 4 3s are 12x square, 15 2s are 30x plus 4. So d by dx, dy by dx is written as d square y by dx square. Read as d square y by dx square and is called the second derivative of y with respect to x, while dy by dx is called the first derivative. Again, the second derivative here being a function of x can be differentiated again, and d by dx, d square y by dx square. Third derivative, it becomes third derivative. So d by dx of 12x square plus 30x plus 4. So 12 2s are 24x plus 30x. So 30 plus 4 constant 0. So third derivative is 24x plus 30. Next example, if y is equal to a raised to mx plus b raised to minus mx, prove that d square y by dx square is equal to m square y. So dy by dx is equal to d by dx a raised to mx plus b raised to minus mx is equal to a into m e raised to mx minus b into m into e raised to minus mx. d square y by dx square is equal to d by dx dy by dx is equal to d by dx a m e raised to mx minus b m e raised to minus mx. am square e raised to mx plus bm square e raised to minus mx. m square common, a into e raised to mx plus b e raised to minus mx. This is the y. So you can write is equal to m square y. Geometric interpretation of the derivative. Let f of x represent the curve in the figure. We take two adjacent pairs p and q on the curve. Let f of x represent the curve in the figure. We take two adjacent pairs p and q on the curve whose coordinates are xy and x plus delta x, y plus delta y. P and q coordinate. This is the curve. The slope of the chord TPQ is given. TPQ is given by del y by del x when del x tends to 0, q tends to p, TPQ becomes the tangent at P. Limit delta x tends to 0, delta y by delta x is equal to dy by dx. The derivative of f of x at a point x represents the slope, or sometimes called the gradient of the curve of the tangent to the curve y is equal to f of x. At the point x, if delta x tends to 0, limit delta x tends to 0, del y by del x exists for a particular point, say x is equal to a, and f of a is finite, we say the function is differentiable at x is equal to a and continues at that point. Now example, find the gradient of the curve y is equal to 3x square minus 5x plus 4 at the point 1, 2. Gradient means dy by dx. So here dy by dx is equal to d by dx 3x square minus 5x plus 4. 3 constant, d by dx of x square minus 5 dx by dx constant, so 0. 3x square 2x into 2x minus 5 into 1, so 6x minus 5. Here point is given 1, 2, okay. So xy, so x is equal to 1, y is equal to 2. Put the value of x, 6 into 1 minus 5, 6 minus 5 is equal to 1. Thus the gradient of the curve at 1, 2 is 1. Summary. Remember it, okay, carefully. D by dx x raised to n is equal to nx raised to n minus 1. D by dx e raised to x is equal to e raised to x. D by dx of a raised to x is equal to a raised to x log a. D by dx of constant is equal to 0. D by dx e raised to ax is equal to a into e raised to ax. D by dx of log x is equal to 1 upon x. D by dx c f of x is equal to c f dash x, c being constant. Function and derivative of function. H of x is equal to c into f of x, where c is any real constant. So d by dx h of x is equal to c d by dx of f of x. H of x is equal to f of x plus or minus g of x. So d by dx of h of x is equal to d by dx of f of x plus or minus d by dx of g of x, sum or difference of the function. H of x is equal to f of x into g of x, product of functions. So d by dx of h of x is equal to f of x as it is, d by dx g of x plus g of x as it is, d by dx of f of x. H of x is equal to f of x by g of x. D by dx h of x is equal to g of x, d by dx of f of x minus f of x d by dx of g of x upon g of x whole square. H of x is equal to f into g of x. So d by dx h of x is equal to d by dz f of z, dz by dx, where z is equal to g of x. Applications of differential calculus. In this chapter, we have discussed the concept of differentiation. Differentiation helps us to find out the average rate of change in the dependent variable with respect to change in the independent variable. It makes differentiation to have applications. Various scientific formula and result involves rate of change in price, change in demand with respect change in output, change in revenue obtained with respect to change in price, change in demand with respect to change in income, etc. Okay. So first, rate of change in quantities. Let the two variables x and y such that y is a function of x. Differential coefficient dy by dx represent the rate of change of y with respect to x. Second one, in other words, the expression the rate of change of a function means the derivative of the function. Third one, we write f of x in place of y and f dash x in place of dy by dx. Cost function. Total cost consists of two parts, variable cost and fixed cost. If C of x denotes the cost producing x units of a product, then C of x is equal to V of x plus f of x, where V of x denotes the variable cost and f of x is the fixed cost. Variable cost depends upon the number of units produced, value of x, whereas fixed cost is independent of the level of output x. For example, average cost AC or C bar, total cost upon output. C of x, total cost, output is x. Average variable cost AVC, variable cost upon output, variable cost is V of x, output is x. Average fixed cost upon output, so f of x upon x. Marginal cost. If C of x the total cost producing x units, then the increase in the cost in producing one more unit is called marginal cost at an output level of x units and is given as dc by dx. Marginal cost MC is equal to rate of change in cost C per unit change in output at an output level of x units dc by dx. To increase profits of a company may decide to increase its production. To increase the profit, you have to increase the production. The question that concerns the management is how will the cost be affected by increase in production. Economists use the marginal cost to answer the question. Example 1. The total cost function of firm is, where is the total cost and is output. A tax at the rate of rupees 2 per unit of output is imposed and the producer adds it to his cost. If the market demand function is given by, where rupees p is the price per unit of output, find the profit maximizing output and price for maximum profit. After the imposition of tax of rupees 2 per unit, the total new cost is C of x is equal to 1 by 3x cube minus 5x square plus 28x plus 10 plus 2x. R of x is equal to px. So it is 2530 minus 5x into x. So 2530x minus 5x square. P of x is equal to R of x minus C of x. R of x 2530x minus 5x square minus C of x 1 by 3x cube minus 5x square plus 30x plus 10. So 2530x minus 5x square minus 1 by 3x cube minus plus 5x square minus 30x minus 10 minus 5x square plus 5x square cancel. 2530x minus 30. So it is minus 1 by 3x cube plus 2500x minus 10. For maximum total profit, P dash x is equal to 0. So minus x square plus 2500 is equal to 0. So x is equal to x square is equal to 2500. So x is equal to under root of 2500. So plus or minus 50. Output cannot be negative, so x is equal to 50. So x is equal to 50. P double dash x is equal to minus 2x minus 2 into 50 is equal to minus 100 less than 0. Thus the profit is maximum at x is equal to 50. Putting x is equal to 50 in the demand function, the corresponding price is P 2530 minus 5 into 50. So 2530 minus 250 is equal to 2280 rupees. Example 2. The cost function of a company is given by C of x 100x minus 8x square plus x cube by 3. Where x denotes the output, find the level of output at which marginal cost is minimum. Second, average cost is minimum. Here m of x minus marginal cost is equal to C of x. Take the differentiation of C of x. D by dx 100x minus 8x square plus x cube by 3. So 100 minus 8 to the 16x plus 3x square, 3 cancel, x square. A of x average cost, C of x by x. Remember the average cost equation, C of x by x. So 100 minus 8x plus x square by 3. M of x is a maximum or minimum where m dash x is equal to minus 16 plus 2x is equal to 0. So minus 16 is equal to minus 2x. So x is equal to 16 by 2 is equal to 8. M double dash 8 is equal to m double dash x where x is equal to 8. 2x is equal to 2 greater than 0. Marginal cost is minimum at x is equal to 8. A of x is maximum or minimum when a dash x is equal to minus 8 plus 2x by 3 is equal to 0. So 2x by 3 is equal to 8. 24 by 2 is equal to 12. 2 12s, so 12. A double dash 12, a double dash x, x is equal to 12. 2 by 3 greater than 0. Average cost is minimum at x is equal to 12. A of x average cost is equal to 100 minus 8x plus x square by 3. 100 minus 8 into 12 plus 144 by 3. 100 minus 96 plus 48. 4 plus 48 is equal to 52. Next, revenue function. Revenue R of x gives the total money obtained, total turnover, by selling x units of a product. If x units are sold at P per unit, then R of x is equal to P into x. Marginal revenue. It is the rate of change I, revenue per unit change in output, if R is the revenue and x is the output. Then MR is equal to dr by dx. Profit function. Profit P of x, the difference between total revenue R of x and total cost C of x. P of x is equal to R of x minus C of x. Marginal profit. It is rate of change in profit per unit change in output, dP by dx. Example 3. A computer software company wishes to start the production of floppy disk. It was observed that the company had to spend rupees 2 lakhs for the technical informations. The cost of setting up the machine is rupees 88,000. The cost of producing each unit is rupees 30. While each floppy could be sold at rupees 45. Find the total cost function for producing X floppies and the break-even point. fixed cost rupees 2 lakh plus 88,000 setting up the machine. So total cost is 2 lakh 88,000. If C of x be the total function for producing floppies, then C of x is equal to 30x plus 2,88,000. The revenue function R of x for sales of x flop is given by R of x is equal to 45x. For break-even point, R of x is equal to C of x. So 45x is equal to 30x plus 2,88,000. 45x minus 30x is equal to 2,88,000. 45 minus 30, 15x. 88,000. So x is equal to 2,88,000 divided by 15. So the answer is 19,200, the break-even point. Example 4. A company decided to set up small production plant for manufacturing electronic clocks. The total cost for initial setup, fixed cost, is rupees 9 lakhs. The additional cost for producing each clock is rupees 300. Each clock is sold at rupees 750. During the first month, 1,500 clocks are produced and sold. What profit or loss the company incurs during the first month when all the 1,500 clocks are sold? Second, determine the break-even point. Total cost of producing 20 items of a commodity is rupees 205, while total cost of producing 10 items is rupees 135. Assuming that the cost function is a linear function, find the cost function and marginal cost function. Now the solution. The total cost function for manufacturing into clock is given by C of x is equal to fixed cost plus variable cost to produce into number of clocks. So 9 lakh plus 300x. The revenue function from the sale of x clocks in given by R of x is equal to 750 into x, 750x. So profit function P of x, R of x minus C of x. So 750x minus 9 lakh plus 300x. 750 minus 300, 450x minus 9 lakh. Profit when all 1500 clocks are sold. So P 1500. So 450 into 1500 minus 9 lakh. So it is 15 5 75. Six, 7, 5 minus 9 lakh is equal to minus 2,25,000. Thus there is a loss of rupees 2,25,000 when only 1500 clocks are sold. Minus sign is the sign for loss and plus sign is the sign of profit. Okay, remember it. At the break-even point, R of x is equal to C of x. 9 lakh plus 300x is equal to 750x. 750 minus 300, 450x is equal to 9 lakh. So x is equal to 9 lakh. 450, 0 cancel. 45, 2 is 90, 2000. X is equal to 2000. Hence 2000 clocks have to be sold to achieve the break-even point. B. Let cost function be C of x is equal to ax plus b, equation number 1. x being number of items and AB being constant. C of x is equal to 205 for x is equal to 20. C of x is equal to 135 for x is equal to 10. Putting this value in equation 1. So 205 is equal to 20a plus b. 135 is equal to 10a plus b. Equation 2 minus 3. 205 minus 135. 20a plus b minus 10a minus b. Plus b minus b cancel. 20 minus 10. 10a. 70. So a is equal to 7. To find out the b, put the value of a into equation 3. So 135 10 into 7 plus b. 135 minus 70. 65. Required cost function is given by c of x is equal to 7x plus 65. Marginal cost function c dash x is equal to d by dx 7x plus 65. It is 7. Marginal propensity to consume. The consumption function c is equal to f of phi expresses the relationship between the total consumption and total income y. Then the marginal propensity to consume is defined as the rate of change consumption per unit change in income dc by dy. By consumption we mean expenditure incurred in on consumption. Marginal propensity to save. Saving S is the difference between income I and consumption C. So ds by dy. This lecture is over here. Next time we will solve the questions of exercise. Okay. So see you soon. Take care.